Welcome to the 8-Bit Shack. Today I'm going to be looking at one of these, a Commodore power supply, but not what you would normally think of a Commodore power supply. This is a power supply for a Commodore 16. For those who don't know what a Commodore 16 was, it was a computer that Commodore released in 1985 for about $99. And that's so I'm quite interested to see what's inside and what it's fixing. So let's get across to my workbench. I have the Commodore 16 power supply on my workbench, but before I do anything with it, I just want to compare it to a Commodore 64 power supply. I have an old style one here, so I just put them side by side, and as you can see, the Commodore 16 power supply is a lot smaller and a lot lighter. And if I compare it to the newer style Commodore 64 power supply, again it is a lot smaller and a lot lighter. So there we have it. Let's move them out the way. Now before I take it apart, I just want to do a quick visual on it, so just quickly turn it apart. So we have the label here on the bottom. It has a part number 251539-04, and where it was made in West Germany, and it states its input voltage of 240 volts AC, 50 Hz, and output voltage of 9.5 volts DC at 800 milliamps, which gives us 7.6 watts. See what else we've got. Well, we have a mains lead here. It's connected to an UK mains plug, in an old style one at that. As you can see, the mains wires are hanging out of the plug, so I'm going to have to make those good, or it might be better if I just replace the entire plug. So that's something to do a bit later. What else have we got? So let's see, we have the power lead itself. It is a 2.1mm DC barrel jack. It's a little bit different to the Commodore 64 power supplies that we're putting side by side. On the 64 they used a DIN style connector, so there's the two connectors side by side. Having a look around at the power supply, we can see that the plastic base has sprung away from the main plastic body, so I suspect it's been dropped, or it's been stood on, or it's suffered some other nasty accident in the past. There's also a bit of rattle inside, so I think something has broken off when it was damaged. So let's take it apart. We have 3 Phillips screws, so I'll just start off at this one here, take it apart. Coming out quite easily. There's one. This one's a bit. That's 2. The last one, the 3rd one. So just and there is 3. So let's open it up and see what we have inside. Okay, let's have a look. There's the case. Yep, there's some loose bits in there, some bits of plastic. Put them there. So we'll take this off. So that's what we've got. So there's There's the plastic here. So what we have is we have a small step down transformer. So there's the mains coming in, there is the AC coming out, a small printed circuit board. Let's see what we have on the printed circuit board. We have, I don't can see it very well, but we have a capacitor, a bridge rectifier, and a fuse. There doesn't seem to be any value on the capacitor walls, or well, maybe something underneath this piece of foam. So let's see, so it says, yeah, it's 4,700 microfarads at 16 volts. Let's take the camera so you can see it there. And we have its markings positive and negative. So just looking at the case itself, it looks like the bits of plastic that snapped off were used to locate the transformer, and it looks like the transformer and the printed circuit board. So I'll have to think of a way of making that good. One of the things we know about these types of old electrolytic capacitors, that they can be a problem as they dry out with age. So what I'm going to do, I'm going to pop this one off the board and basically measure it, and quite possibly replace it with a modern one of the same value and voltage rating. I've got my desoldering gun here, so I am going to desolder the cap and then measure its value and see if I need to replace it. So just, you can hear it there, so I'm just going to make a note of the positions of the cap. So positive is here, so let's put a positive there. So when I come to solder it back, I put it back in the right position, so just flip it over. Oh, that should be them 2 pins there. Get the soldering gun. There you go, it's coming off this motor. There you go, a little bit more. Okay, that one's almost done. Right, so it comes off. A little bit of wiggling, so one line's, yeah, it's come off. So there we have the capacitor of the PCB. So it says what, about 40 years old. So I'm going to test this capacitor, and to do that I'm going to use this rather fancy capacitance meter and ESR meter. It cost about £90. I'll put a link to it in the description. And so let's get going. So switched on. So there we go. Put it there. Hope you can see that. So just find a couple of pins. There we go. So first one. Second one. Alright, it's doing its thing. Measuring the ESR. Saying its ESR is 0.02 ohms and its capacitance is 5,268 microfarads. Now this is a 4,700 microfarad capacitor, so that's probably about 10% or 15%. So back in the day, these types of capacitors would have had a rating of plus or minus 10% or even plus or minus 20%. So that's probably somewhere in between. So just going to check to see what the ESR rating should be for this value of capacitor. Let's get a little booklet that came with this. So let's have a look. It's got a little table here somewhere. So I don't know if you can see that. So it's 4,700 microfarads, 16 volts. So according to the book, it should be 0.07 ohms or less, and this said it was 0.02 ohms. So believe it or not, this 40-year-old capacitor is still good. So I'm going to solder it back into the printed circuit board. Right, I'm going to solder this now. So got my iron, just clean it, the tip and tin it. There we go. That's one pin done. Do the other pin. There we go. That looks good. Okay, yeah, looks good. Just check the markings. Positive, positive. So yeah, so that's soldered good. So before I put this in the case, I just want to check this fuse. So I'll just bring in a multimeter. So I'm just going to put it there. Just measure the resistance. Yep, so that fuse is good. So I think we can put this back into its case. Before I put the power supply back into the case, I just want to do a quick continuity check on the mains and also the DC. So I'll start with the mains. I've made good the mains wires which were loose, so I'm just going to flip this over. So I'm going to go, so obviously this is a UK plug, so I'm going to go from live there to that pin there. Okay, I've got about 0.4 of an ohm, so that looks to be good. Likewise, I'm going to go from this pin here, which is the neutral, to this pin there. Yeah, 0.3 of an ohm, so that looks good. Right, I'm going to check the DC power now. So if I just pull up a data sheet here, the outside is the positive and the inner is the negative. So I'll start with the outside. Now I know the fuse, this fuse here is positive, so I know the fuse is good. So I'll just, okay, I'm not getting anything on the positive. So see if I can get a better contact there. Nope, I'm not getting anything on the positive, so that's not a good sign. Right, the negative is this one here, so I'm just going to flip this over. Right, and try on the inner there. Oh, this is not good at all. Looks like this looks like this cable is US. It's broken. Right. Can't see any obvious breaks in it. It's soldered there. I know that fuse is good. What can I do? Right. I did prepare for this because I do have a spare DC barrel jack here. So what I'm going to do is I think I'm just going to cut off this. I'm just going to cut off this and measure it. So I'm just going to give it a few minutes. Cut off about 2 or 3 inches down. Let's cut off there. Pull this back a bit. Okay. I've got some strippers, some wire strippers. So just gently remove the outer sleeve. Alright. Let's try it again then. So put it on this one here. Put it onto there. Okay, so it looks like it might just be the plug, DC barrel. That's so. I've got a circuit there. Do this one next. Okay, looks like I've got a circuit there. So okay, so it looks as if this is faulty, which might explain why I wasn't getting any power out of it. So I'm going to solder on a new one, so it shouldn't be too hard to do. So there we have it, a new plug on the end. So this faulty one can go in the bin. Right, I'm gonna just test the continuity of this. So I'm just going to use basically one of these to help me a bit. So I have my basic multimeter here. So I'm going to the negative there, which is on the inside. So that's going to be this one here. Yep, so I'm getting about 0.5 in ohm, so that's pretty good. I'm going to go to the positive now. Which I know is this one here. Again. So that looks all good. So I'm going to put this back in the box. Now, as I said before, I've used some double-sided pads, basically sticky pads, to hold the PCB in place. So I'll just take off out there and just get this into position. Yeah, it slides in there nicely. Put this there. On that side is screw pillar. Let's push this down so it's good. So that's now nice and secure in the base. Put the top on now. Well done. Nice click there as the top and bottom went together. So put the screws back in. Quickly screw this back together. There's one screw in. There's another screw in, and for the last screw. Right, so there we have it. Now we have fixed a faulty jack plug. We've made good the mains plug, and the two halves of the cases now are properly together. And so what I'm going to do is basically put this into the plug this into the mains and just check that we have the 9 volts or so, or the 9.5 volts coming out of here. I've got the Commodore 16 power supply back on the bench. I've fixed all the things that need fixing. So next thing I'm going to do is test its output. So I've got one of these DC barrel jack adapters. It's a 9.5 volts DC power supply. And it's unregulated. So I'm expecting about 12 or 13 volts. If it's got no load attached. So let's measure it. I've got my DC. I've got my multimeter set to DC voltage. So let's just see what we have. Okay, I've got about 13.7 volts. A little bit higher than I was expecting, but it's in the ballpark. So the next thing I'm going to do is test this with a basic electronic load I have here. This is a 60 watt electronic load. I believe its model number is ZBP30A01. It's been around for quite a while. You can buy it online for about $20 or basically £20. So I'm just gonna plug in the power supply. I've got this connected to. So, right. So, the label says this is 9.5 volts up to 850 milliamps. So I'm going to start off at about 400 milliamps and then slowly basically ramp that up. So, just get the cable out the way. It just started then. So at 400 milliamps. So the 13.7 volts has dropped now to 10.9 volts. So let's just ramp this up again. At 500 milliamps, it's dropped down about 10.1 10.5 volts. At 600 milliamps, it's about 10.1 volts. At 700 milliamps, it's dropped down about 9.7 volts. And at 800 milliamps, it's about 9.4, 9.5 volts. So it looks to be a pretty bang on. I'll try it at 900 milliamps. Okay, it's dropped down about 900 volts, but that's going beyond what's on the label. As the label says, its maximum output is 850 milliamps. So I'm pretty happy with that. So what have we done? Well, we fixed the broken case. We've fixed the rather dodgy mains plug, and we've also replaced the DC barrel jack because that had an open circuit. So what next? Next thing is we have the Commodore 16 board to look at, and so I think that's going to be my next video. So thanks for watching. I hope you enjoyed the 8-bit shack. If you did, please consider leaving feedback, a comment, or even subscribing.